All right, so welcome to day 6. It's actually not really day 6. It's like day 4, day 5, but that's what I named it before, or that's what they called it. So we're going to be talking about transformation. So we've talked a little bit about the basic vocabulary for geometry. So today is going to be just an introduction on transformations. So just as an introduction, most objects can be represented as a collection of many geometric objects. However, this geometric object may not be in their original forms. Some may be twisted, stretched, turned, and so on. Wow, I really need to do some spell checking and grammar checking. These necessities this necessitates the fact that before using these geometric objects, we understand these kinds of formations and deformations done. This is basically known as transformations. In this lesson, we are going to introduce a concept about most common transformations. So this refers to a change in a shape and position of an image from one form or location to another. So transformation is just a change. So the key word here is change. So transformation is a change. So copy that down. Again, you're not going to copy all this stuff word for word, but the basic understanding, you guys will copy down whatever you really need. So transformations, again, it's a change in shape and position. The most common transformations are translations, reflections, rotations, and dilations. We're not going to deal too much with dilations. We're going to deal with the top 3, translations, reflections, and rotations more in this chapter. Apart from these, we have others such as stretch, shear, and shear. We're not going to even deal with those two in this chapter. We refer to the initial figure as the pre-image. So the first image is going to be called the pre-image. The final figure is going to be known as the image. So translations. This refers to a slip acting on an object. The slip can be in any direction. Because the pre-image is made to slip, its shape, orientation, and size does not change. What I mean by slip is just a movement. So we are moving or the shape. So it's not changing its shape. It's not getting bigger or smaller. It's not flipping to the other side. It's not turning. It's just going from like where my cursor is right now to like over here. My cursor still looks the same, but I just moved it. That's what a translation means. It means my cursor's here, now it's over here next to the. Okay? So this is a pre-image. So it's the first image is a pre-image. When I do something to it, it becomes the image. So like this is a example of a translation because I moved this image over to this side. So reflection, this is a transformation where the object is flipped about a point or a line. The point or the line along which flipping occurs is called the mirror line. So it's like looking at yourself in a mirror. So consider the line or the point that you're given as the mirror, and your image is going to show up on the other side. The image and the pre-image, as a result of reflection, are the same size and shape and are at an equal distance from the mirror. So here's my pre-image. Here's my mirror. The image isn't going to change. The size isn't changing. The distance between this line and that line, which apparently it's actually kind of is, but it's not supposed to be, isn't going to be any different. It's just flipped to the other side. Rotation. This is a transformation where an object is turned, to rotation means turning, from a fixed point. The fixed point where rotation occurs is called the center of rotation. So where you're going to rotate it at is the center of rotation. And the angle through which the object is flipped is called the angle of rotation. So that angle that you have, or that it told you to rotate, is the angle of rotation. Sorry about that sound. The size and the shape of the image and the pre-image does not change. So here is my pre-image. Here is the center of rotation. So this dot is the center of rotation. And if I'm supposed to rotate it that way, this is now my image. This part right here, this angle right here, would be the angle of rotation. Okay? So dilation. This refers to a reduction or increase. So getting bigger or smaller or bigger, sorry, in shape of an object by a factor. As a result, the size changes, but the shape and orientation of the result object does not change. This is done, so here's my pre-image. If this is my center of enlargement, so this is a point where I'm going to make it bigger or smaller. If I draw this line and then connect my dots, I would have this image right here. So this is the second image. So my pre-image is here. If I use this as my center of enlargement, so the point where I'm going to make it bigger or smaller, I would have my image be this size. If I went from this size to this size, then it would be called the center of reduction. So depending on if you're getting bigger or smaller, it's the vocabulary you would use. Again, we are not dealing that much with dilations. So if this is a little confusing, don't worry about it. You'll deal with this a little bit more in later years. So transformations as a function. Transformation is a function that maps the elements in the domain to that of a range. The domain is composed of all points on the pre-image, while the range is all the points on the image. Since every point on the image is generated by a point in the pre-image, a transformation is termed as a one-to-one function. We would like to find out the kind of images under different transformations. So the pre-image point is x and y. Will be mapped to an image point where I'm adding a number to x and I'm adding a number to y. It is a when we do this, this is a translation. So depending on where it's telling me to go, if it tells me to go up or down, left or right, is if I'm going to be adding or subtracting here. If it tells me to go up and down, I'm going to be adding or subtracting the y. If it tells me left or right, then I'm going to be adding or subtracting on the x. So here's my example. I'm given 2, 4. Is translated 4 units downward. What would be its image? So I look at my key terms. Translation means I'm going to be adding a number to either my 2 or my 4. It tells me I'm going 4 units downward. So I'm going down. So if I'm thinking of my x and y, which one goes down? Is it my 2 or is it my 4? Which one goes down? The x or the y? If you said y, then you're correct because y is my up and down. So since I'm going down, I'm going to subtract 4 from this 4. So if I did that, I get this. 4 minus 4. 4 minus 4 gives me a 0. My 2 stays the same, so my solution point would be 2, 0. So this would be my new point. So 2, 4 would be my pre-image. 2, 0 would be my image. A reflection, on the other hand, is going to have like be a reflection on the mirror line. So we're going to flip it over the mirror line. So depending on what your mirror line is going to be, your X and Y are going to change slightly. So here's a list of the very common ways that your pre-image is done. I would strongly suggest you copy this because these are the common ones you're going to see on your test and on your homework. So if you're flipping it over or reflecting it over the y-axis, your x, whatever number is on your x, is going to be negative. Your y stays the same. If you're flipping it over or reflecting it over the x-axis, your y is going to be negative. Your x stays the same. If you're reflecting it over the origin, both your x and y are going to change, and then so on and so forth. All right, so again, I strongly suggest that you guys copy this down and use it for later. So we're going to have an example. So this is going to be reflected. So 2, 4 is going to be reflected over the y equals x. And then about x equals 3. What would be its image? So let's do the y equals x. So we have 2, 4. So let's go back and say y equals x. That just means that my x and my y are going to switch over. So if I look at this, 2, 4, that means I'm going to flip this over. So I'm going to have sorry, 4 and negative 2. Wow, that's so horrible. I apologize. All right. So my thing is going to be 4, negative 2. Then I need to look at x equals 3. So if I look back, x equals a number means that I'm going to have 2c minus x. So 2 times c minus x. So I look at here. My x is 4. 2 times 4 is 8. Minus 3 is 5. Ooh. So it should be like this. Sorry. I'm getting all confused. So 2 times 3 is 6. 6 minus 4 is 2. Sorry, I apologize. I don't know what I was doing before. So 2 times 3 is 6. 6 minus 4 is 2. So my new point would be 2, 2. So this would be my final answer. So rotations are when the pre-image is reflected. We get different images based on different angles and center of rotation. So depending on if it tells us to go clockwise or counterclockwise, we're going to have something like this. So again, I would copy this down and see if you guys can, so that you can use it for later on. So copy this down. So rotation, I need it to negative 270. So if I look at 270, it's going to be switch, x and y, and my y is going to be negative. So I'm going to have negative 4 and 2. Sorry. All right. Dilation, again, I'm going to kind of skip this because we're not really going to deal with that. And that's about it for right now. So you guys can practice those later on today. Thank you.